In our last video, we are going to be combining reflections and translations and see how that affects our graph. First, identifying our parent function. In this case, we've got the inverse function or the hyperbola. When we've got the x in the denominator, I still identify a critical point, but this time what the critical point tells us is what the asymptotes are. So because our graph got shifted right 5 and up 2, our asymptotes are now going to be the equations x equals 5 and y equals 2. So you could identify those equations instead of the critical point if you would like to. Domain, looking at this function, what's in the denominator, that x minus 5 cannot equal 0. So therefore x cannot equal 5. And then thinking about the output with the parent function, it's 0. So because this got shifted up 2, this time our range is y cannot equal 2. We've got a reflection on this one because it is not grouped with the x. It is a vertical reflection, but that doesn't affect the domain or range. We're just going to have our hyperbolas in different quadrants. So for our parent function, 1 over x, substituting in to get our t-chart, we'll have negative 1/2, negative 1, undefined, 1, 1/2. Because we have a vertical reflection, that's going to change all of our y values to be opposite, because I don't have room for another column. I'm just going to throw those opposite signs in. And we're going to start by plotting our asymptotes. So again, the domain and range give us our asymptotes, otherwise that critical point, or looking at the translations, we're shifting our asymptotes the same way we're shifting the rest of the graph. Scaling these by 2 as well. We've got x equals 5 for our first asymptote. And our second one is y equals 2. So where those asymptotes meet is kind of our new origin. That's the critical point that I identified. And that's where we'll be starting to plot when I talk about the direction from the critical point. So here our first direction gives us left 2, up 1/2. So from where those red lines are meeting our asymptotes, left 2, up 1/2 is my first point. Left 1, up 1 is my second point. And then you have to remember the shape of the graph to get the rest sketched, because this doesn't give you much of an idea. So it's the curve that goes between the asymptotes. These points will just get you in the right quadrant to sketch your graph. Next, we're going to go right 1, down 1, and right 2, down 1/2, and sketch our curve between our asymptotes again. Next graph is the inverse square, so identifying our parent function again. This one is the one that looks like a volcano, similar to the inverse function, except for both halves of the graph are above the x-axis. So this time our graph got shifted left 3, up 1, so that's our critical point, or the equations for our asymptote are x equals negative 3 and y equals 1. Domain, what's under the fraction bar, it's in the denominator, cannot equal 0. So x cannot equal negative 3. Of course, we can also get these values from our critical point once we've identified that. Range y cannot equal 1. Parent function, substituting into the inverse square, and again we've got a vertical reflection, so we'll have to come back to that. We got 1/4, 1, undefined, that's a D, 1, 1/4. And the vertical reflection makes all of our y values opposite. Starting off by graphing the asymptotes through negative 3, I'm going to scale all these by 2 again. And 1. So another thing to have in your mind is with that vertical reflection, it flips it below the x-axis. Or if it's already below, it'll flip it above. Since both these pieces are typically above, our graph is going to be below the x-axis now. So using our directions from where those asymptotes meet, our new critical point, left 2, down 1/4, left 1, down 1. And again, using those asymptotes to sketch the curve. And this curve is more sharp than the hyperbola, but it's kind of hard to tell with our scales. Right 1, down 1, and then right 2, down 1/4. So it gets closer to those asymptotes faster is what happens. One more, we've got to look at a step function. So our parent function is our step function. No critical point with the step function because of the way that it's set up. Domain, you can round any number. So we've got all real numbers. And the range, since we are shifting it using integers, the range will still be all integers. So that's a z with an extra slash through it. Kind of hard to tell on this. So what we do is when I think about this, I think about shifting my first bar. So for the parent function, your first bar looks like this. So I think about shifting that first bar, and this time I'm scaling them by ones. Whichever direction it tells me to. Now here's where we need to be careful because that x is negative. So if we set this equal to 0 and solve for x, I'm going to add x to both sides. It's actually a left shift. This is where that asylum analogy kind of falls apart. It doesn't really. If we factor out the negative, then it's opposite. We see a +7. It's really a left shift. So our asylum analogy still works. Be careful when you've got something you need to factor out first. So this is actually a left shift, left 7, which now that I scaled those all by 1, I'm not going to have room for. So I'll go ahead and rescale. And it's a horizontal reflection. So that horizontal reflection is going to change where the solid and open circles are. If you think about flipping it from left to right. So now we're going to have open circles on the right, on the left, and closed circles on the right. And we're going to shift it up 2. So let me change my parent function bar since I'm changing the scaling. So here's our parent function bar, and I'm going to shift that left 7 and up 2, and you will also see the open and closed circle flip as well. Sorry, I went the wrong way. It starts here and it got flipped that way. And then once you have your first bar, you can continue that pattern because it always goes down 1 or up 1 as long as there's no stretching. So it would continue forever off to the right as well. And here is your you try question.